Unit 6 is quadrilaterals and other polygons. Let's start off with lesson 6.1, Polygon Angle Sum Theorems. Let's learn something new. Objectives. The students will be able to show that the sum of the exterior angles of a polygon is 360 degrees and use that to solve problems. That's using the Polygon Exterior Angle Sum Theorem. And the students will be able to show that the sum of the interior angles of a polygon is a product of 180 degrees and 2 less than the number of sides, and use that to solve problems. That's the Polygon Interior Angle Sum Theorem. Polygons. Let's see what those are to begin with. Polygons are closed plane figures formed by line segments that meet at a common point. These line segments, also known as sides, meet at a common point, which is called a vertex. Two sides may not be collinear. Classification of polygons according to the number of sides. So 3 sides is a triangle. We know that. We've studied that for 4 units. Quadrilateral is the generic name for a 4-sided polygon. Pentagon has 5 sides, whereas a hexagon has 6 sides. Heptagon has 7 sides. Octagon has 8 sides. Nonagon has 9 sides and decagon has 10 sides. One that you will also see popping up sometimes is a 12-sided polygon called a dodecagon. The sum of the measures of the interior angles in any polygon can be determined by the number of triangles that can be drawn within the polygon. Complete the table below and look for a pattern to find the sum of the degrees of any polygon. So a triangle, we already know a triangle has 3 sides, 1 triangle, and the sum of the interior angles is 180 degrees. We've used that for a long time now. Everything from day one's fair game. Quadrilaterals has 4 sides. 2 triangles can be drawn in using a diagonal from a common vertex. And 2 times 180 is 360. Pentagon, 5 sides, 3 triangles, 540 degrees. Hexagon, 6 sides, 4 triangles, 720 degrees. So the rule for interior angle sum is n minus 2, number of sides, minus 2 times 180 degrees. So polygon interior angle sum, the segments that connect the non-consecutive vertices of a polygon are called diagonals. That's what we were drawing in that last slide. Drawing all the diagonals from one vertex of an n-gon, that means it has n sides, separates a polygon into n minus 2 triangles. The sum of the measures of the interior angles of the polygon can be formed by adding the interior angles of those n minus 2 triangles. So here is a formula, interior angle sum formula. If n represents the number of sides of a polygon, then the sum of the interior angles, capital S, can be found by using this formula. S is equal to the quantity n minus 2 times 180 degrees. Let's do some. Find the sum of the measures of the interior angles of each polygon. Use the formula to show all work. Number 1, 15 gon means it has 15 sides. There's our formula. So S equals 15 minus 2 times 180, which is 13 times 180 degrees. 2,340 degrees is the angle sum, interior angle sum, for a 15 gon. Let's do a 21 gon. Plug in 21 in place of n. Simplify 19 times 180, multiply that together, 3,420 degrees, 48 gone. All right, so now we're putting 48 in place of n, simplify, and 8,280 degrees, 36 gone. Plug in 36 for n, simplify, 6,120 degrees, internal angle sum for a 36 gone. Types of polygons. Regular polygon is a polygon that has all equal sides and equal angles. That's what makes it regular, and that's important to know. Irregular polygon is a polygon that has unequal sides and angles. Okay, so it doesn't necessarily have to have both, but it's got to have both equal sides and equal angles to be regular. If not both sides and angles are congruent, then it is irregular. Regular polygon, the measure of the single interior angle in a regular polygon, can be found by dividing the sum of the interior angle measures S by the number of sides n. So here's our formula. N minus 2 times 180, that is the sum of the interior angles. But if it's regular, all the angles are the same, so you can divide by n to find each one. Examples in practice. Find the measure of each interior angle of a polygon. Show the formula and show our work. Regular pentagon. Pentagon has 5 sides. Formula S, sum of the interior angles of the polygon divided by n. Because it's regular, each of them is the same. So there's our formula. Pentagon. Plug in with 5s. Simplify. Calculate. 108 degrees. If it's a regular pentagon, each of the interior angles of that regular pentagon is 108 degrees. Regular 18 gone. Same formula, plugging in 18 for the ends. Simplify, simplify again. 160 degrees is each interior angle of a regular 18 gone. Exterior to interior angles, I think this can be very helpful. We're actually going to talk more about the 360 in a minute, but the sum of all exterior angles of a convex polygon is 360 degrees. So in that first one, the light green are all the exterior, the dark green are the interior. In the middle, the exterior are the light purple or fuchsia, and the interior are the purple. On the last one, the exterior are the orange and the interior are the brown. The sum of all exterior angles of a convex polygon is 360 degrees, but an exterior angle and its linear pair interior angle, linear pair, big clue, everything from day one's fair game. Linear pair forms supplementary angles. They total 180 degrees. So this can help us with a little shortcut later on to help us find some angle measures. So some of the exterior angle measures. Exterior angles are supplementary to their adjacent interior angles. Already said that. Find the measure of each exterior angle in the polygon below, then give the sum of all exterior angles. So exterior to 79 is 101. Exterior to the 40 degrees is 140, because you know they add up to 180. right? So the 61 is supplementary to the 119. And if we add all three of those together, we get 360 degrees. Next one, exterior. 124 is a linear pair with 56. 76 is a linear pair with 104. 89 is a linear pair with 91. 71 is a linear pair with 109. Add them up. 360 again. Let's do the next one. Each of the exterior angles form a linear pair with its adjacent interior angles. Add them all up and we get 360 degrees. So what can we conclude about the sum of the exterior angle measures of a polygon? It's always 360 degrees. It does need to be convex, please. More examples. Number 7. What is the measure of each exterior angle of a regular hexagon? So the total is 360. Hexagon is 6 sides. So 360 divided by 6 is 60 degrees. Number 8. What is the measure of each exterior angle of a regular 24gon? So 360 divided by 24, each one is 15 degrees. Switching gears a little bit. Number 9. If the exterior angle of a regular polygon is 12 degrees, how many sides does a polygon have? So 360 divided by something gives us 12, but the 12 and the x can trade places. We did that in Unit 8. So 360 divided by 12 gives us x, and x this time is the number of sides, and that is 30 sides. If the exterior angle of a regular polygon is 40 degrees, how many sides does a polygon have? So 360 divided by number of sides is 40 degrees. Switch places. 360 divided by 40 is x. X is the number of sides. Number of sides are 9. Let's see, more practice. Write an example and solve for x. Show all work. Number 11. We have expressions for the interior angles. Let's see, 1, 2, 3, 4 sides. That's a quadrilateral. So all the interior angles added together. So x plus 110 plus 79 plus 55 equals 360 for a total for quadrilaterals. Combine like terms. X plus 244 equals 360. Subtract the 244 on both sides. X is 116. So final answer, X is 116 for number 11. Number 12. Let's see how many sides. 1, 2, 3, 4, 5, 6, 7 sides. Heptagon. Okay, so there's 7 interior angles. Let's add them all up. So x plus 142 plus 150 plus 90 plus 148 plus 140 plus 136 equals 7 minus 2, because it's a heptagon, 7 angles, times 180. Combine like terms. We get x plus 806 equals 5 times 180. X plus 806 equals 900. Subtract the 806 on both sides. X is 94. So final answer, number 12, X is 94. More practice number 13. Write an equation and solve for x. Let's see how many sides we have. 1, 2, 3, 4, 5, 6. Hexagon. So we need to add up all 6 angle measures. A lot of expressions on there. Equals 6 minus 2 times 180. Let's tidy it up by combining like terms. On the left-hand side, we'll have 26x plus 278 equals 4 times 180, or 26 plus 278 equals 720 degrees. Subtract the 278 on both sides. We get 26x equals 442. Divide both sides by 26. X is 17. Final answer number 13 is 17. Number 14, those are exterior angles. We know all of those add up to 360. So the sum of the exterior angles of any convex polygon is 360 degrees. Just said that. There it is to back it up. Algebraic expressions galore. 5x plus 4 plus 4x plus 9 plus 9x minus 6 plus 4x plus 1 plus 7x plus 4, 360. Combine like terms. 29x plus 12 equals 360. Subtract the 12 on both sides. 29x equals 348. Now divide both sides by 29. X is 12. Final answer, X is 12, number 14. We have now finished Lesson 6.1, Polygon Angle Sum Theorems. I hope you learned something new.